This video demonstrates a technique of bolster-less traction suture placement within the tarsal plate that avoids the problems of grey line placement. Most oculoplastic textbooks recommend traction suture placement through the lid margin grey line, which derives its name from the colour of the muscle of rheolin seen through the thin translucent overlying skin. Neither thin skin nor muscle are known for their suture-holding properties, hence the use of bolsters to distribute the traction force. Sutures placed in this way can be painful, distort lash growth, and may cause lid margin necrosis. The tarsal plate, on the other hand, is the strongest part of an eyelid, in spite of being 70% Meibomian gland. It is therefore the best structure into which to place a traction suture. Although the tarsal plate is only 1 to 2 millimeters thick, the Meibomian gland orifices provide a convenient surface landmark for the mid-tarsal plane. The suture is therefore inserted into the Meibomian orifice line. A tapered, non-cutting needle causes minimal damage by separating tissues as it passes, rather than cutting them. Cutting needles risk shredding the relatively thin tarsal plate with each pass and should not be used. A strong 4-0 monofilament polypropylene suture on a 17 mm half-circle round-bodied needle makes an excellent traction suture. To place a traction suture, grasp the full thickness of the lid almost parallel to the lid margin with large forceps and divert it. As the lid is squeezed, the egress of Meibomian secretions identifies the Meibomian orifice line. Enter the Meibomian orifice line with the needle tip perpendicular to the lid margin. Slowly advance the needle within the plane of the tarsal plate, allowing it to follow its curve until it exits once more through the Meibomian orifice line some 10 to 12 millimeters from its point of entry. The needle will sometimes exit too anteriorly through the lash line or too posteriorly through the conjunctival surface of the tarsal plate. In this eventuality, partially withdraw the needle, alter the lid margin angulation, and re-advance the needle. This may need to be repeated until the tip exits in the Meibomian orifice line. Finally, inspect the lid to ensure that the suture has not breached the conjunctiva or skin during its long passage. If an insufficient length of tarsal plate is engaged by too short a pass or by inadvertently missing the tarsal plate, premature failure results. Avoid this by ensuring that the needle entry is perpendicular to the lid margin and in the plane of the Meibomian glands. Allow the needle to follow its natural curve while holding the lid flat to keep the needle within the tarsal plate throughout its passage. A bite length of 10 to 12 millimeters is ideal. Eventual migration of the suture out of the lid is inevitable if it is left in place long enough. This is only an issue with long-term suture tarsorrhaphy. With correct tarsal traction suture placement, no pain or inflammation are seen. In summary, the uses of a temporary tarsal traction suture are many, ranging from simple eye protection postoperatively to stabilizing a lid graft bed or preventing postoperative lid retraction. It is very useful in the management of indolent corneal ulcers. It forms the basis of atraumatic suture tarsorrhaphy as being demonstrated here, which is invaluable in cases of facial palsy pending recovery of function. Remember, it's the Meibomian orifice line, not the grey line, that holds. The tarsal traction suture should become a fundamental component of every eye surgeon's repertoire.